Hi everyone, my name is Tawheed. I'm here to present my poster. My poster's name is Multinuclear Magnetic Resonance of Electrospun Polymer Metal Organic Framework Fibers. So I'll just give you like a summary if time is very short. So basically we are trying to make nanofiltration materials here. So some of the advantage of nanofiltration is that it can be applied in medical industry, in pharmaceutical industry, in water, wastewater management, desalination and everything else. So you can read this later. So nanofiltration is a liquid separation technique where that uses nanometer sized through ports or membrane that pass through the membrane. Nanofiltration membranes have pore size of 1 to 10 nanometer. Membranes that are used are predominantly created from thin polymer fibers. So here we are trying to we synthesize nanofiltration polymers and also nanofiltration metal organic frameworks. So basically, one of their advantages is basically that they have greater interfacial areas. They are very tunable with dependencies on nanoparticles. Like for example, like this, what is the size of the nanoparticles? What is the shape of these nanoparticles? They're tunable with dependencies on the polymers. Additional tuning can also be done through the decreasing or increase of concentrations of them. So here we have synthesized polymers such as PAN, PVP, and PVC. And for the metal organic frameworks, which is basically the integration of the metal ions with organic ligands. So there also we have used here the ZIF-8, zeolitic imidazolite frameworks, which is ZIF in short. So basically, ZIF, in contrast to the pure polymers here, they used or they gave a lot of porous crystalline structures, which allows us to for gas molecules to pass through and can differentiate species on a molecule level. So that's the reason why we have done a comparative study between pure polymers and then the ZIF 8 or the metal organic framework, one of them. So one of the ways you can synthesize these polymers is through electrospinning. One of the electrospinning is basically a widely used nanofiber synthesis method where high voltage is applied to polymer solution. Electrospinning can be the typical components of electrospinning has just only three parts. So the first one is a high voltage power supply. So it needs a DC power supply, a spinneret, which is like this syringe shaped or syringe with polymer solution container, and then the bottom one, which is the electrically grounded collecting plate or drum. So what happened is basically when you put a lot of high voltage pressure or like at a high voltage differences, this solution contains it comes out from the spinner and then it collects on the grounded plate. Now we have studied them or the spectroscopy of these polymers through applying the NMR technique. So NMR technique is a special type of technique which is called nuclear magnetic resonance that gives us the structure or between them on a molecular level, like what's happening on the molecular level, how ductile they are, how flexible they are, because the idea of the nanofiltration materials is basically making materials that can be used for filtration method. So a lot of the qualities, for example, like ductility, the flexibility is very desirable for our case. So that's the reason why you're using NMR technique here. So this is one of the after the synthesize of these polymers. These are some of the pictures you can see here. So for example, like 10% PVC is here, and then it's incorporate or the so 1% ZIF and 10% PVC. So they're both of the same polymers, but here we are incorporating the metal composite fiber, which is ZIF 8 as well. So this is a very plastic type of like texture, and here you have the paper type of texture. So both of them are made of the same polymers, but the texture is quite different. So after that, so this is just a picture here. So basically, after we perform the proton static NMR technique, so some of the details of the NMR technique will be talked when someone asks me the questions here. So after we apply this, we get a spectroscopy. So the spectroscopy actually tells us the all spectra showed asymmetry and the presence of multiple chemically inequivalent components. So because we have different chemical interactions happening on a molecular level between the 10% PVC itself and then also the composite fiber, which is the ZIF 8 and 10% PVP. Another major difference we can see that asymmetry is further enhanced by the addition of the MOF, because when you're adding the MOF, the asymmetry is even much more enhanced because of that. And the differences that you have seen here is that with the increase of the polymer content causes a reduction in the line width. So this is just polymer content is 12% PVP, 14% and 16%. So as you can see that with the increase of the increasing of the polymer contents, the pick or the width of the pick actually decreases. So that's actually good because with the decrease or reduction in the line width, what you can have is that it can have sharper peak. So sharper peak will give us more flexibility and also a better texture for the filtration material. So one of the good thing is that with the increase of the polymer contents, the peaks get narrower. So that's also good for us. The line gives the information of the flexibility polymers. For the future works, because these are just only three samples that we have tried to compare or have some comparative study. In the future works will include even more polymers, for example, polystyrene here. The parameters of the characterization will include MOF type and the concentration, polymer type and concentration, etc. And then here we have done only one type of NMR technique, which is the proton-static NMR technique. But in the future, we are trying to do solid state NMR as well. These are different type of technique that will give us even like different molecular structure and the dynamics of these different molecules as well. So this will give us even like better or like with clear resolution of like what's happening on the molecular level. And additionally, the polymeric solution will be characterized to assess the effect of the hydrogen bonding on the resulting filtration properties of the fibers.